Welcome to AP Biology. Today I want to go over Tree Thinking Challenge 2 because a lot of students struggle with it. So this one tells you to find the one that depicts a different pattern of relationship than the others. So let's look for that. So let's just look at the first one. So I can pick anything up here, but to me it makes sense to look at the ones that are more closely related. So if you look at G and A, it's not that they're sitting next to each other as much because like C and G are also sitting next to each other. But what I want you to look for is the common ancestor. So they share a common ancestor with each other, but nobody else. So that means there was this individual from the past and it gave rise to both of these groups and no other groups. So G and A are the most closely related to each other as opposed to another. So G and A here, if you go backwards from G and you go backwards from A, here's their common ancestor. So it's true there. And then G and A are right here. And if you go backwards in time, here's their original ancestor for all of them, right? So this would be the original, this would be the ancestor for G and A. And then for this one, these are a little bit more maybe tricky to read. You go back in time till where they come together, and here's their common ancestor. So they all have G and A with a very recent common ancestor. Okay, so let's go to the next one. So how about D and E? D and E share a common ancestor with each other, but no one else. And here's D and E with a common ancestor. So that's true here. And then D and E right here. It doesn't matter if it goes ED or DE, as long as they both have this common ancestor here with just each other. And here's D and E. And if you go backwards, here's their common ancestor. So far, all of the trees are the same. Now if I go to the next one over, if I'm going back in time here to this first one and I find this common ancestor, we see that D and E are next most closely related to C. So C is related to D and E. So, this one's different though. If I go back in time, right, for part B, I can see that B is more closely related to D and E than C. To get to C, you would have to go way back to this one, right? So these two are different from each other. So I just have to go down here and see if D and E are more closely related to B, like they are in this one, or if D and E are more closely related to C, like they are in this one. So let's look at it. D and E go backwards in time. Here's the next common ancestor, and it's with B. So it looks like these two are the same in regards to that. And let's do it for this one too. D and E go backwards in time. Here's the common ancestor with B. So these three are the same, and this is the one that is different. Okay, next one. We are looking at a tree here, and it tells you that the ancestor, meaning the ancestor to all of them, tells you it has some traits: long tail, ear flaps, external testes, and fixed claws. It makes sense to me to write this stuff in. So long tail, ear flaps, external testes, because there's a lot of traits. This way we know that these are the traits of the first ancestor here, and then fixed claws. Okay, based on the tree and assuming that all evolutionary changes in these traits are shown, what trait does the sea lion have? So first of all, a lot of my students pick the seal. I don't know, they're trying to rush through, I think. So you want to pick the sea lion. And so if you go from the original ancestor up through the pathway, okay, short tail, that means it doesn't have a long tail anymore. That ancestor uh, developed that adaptation. And we're going toward the sea lion. They have abdominal testes, so we can cross out external testes. And here we have the sea lion. So that means the sea lion should have abdominal testes, a short tail, and then it doesn't say that the ear flaps changed or that the claws changed at all. So we are looking for a short tail. So it's going to be one of these. And then for ear flaps, it does have ear flaps. So we can cross out those, and we're left here. And let's just check abdominal testes. Yep. And fixed claws. Yep. So it looks like D for that one. Okay, last one, I think. So assume in this tree, assume that the ancestor was an herb. So not woody. without leaves. So no leaves. And it says without leaves are seeds, so that means no seeds. Okay, based on the tree and assuming that all evolutionary changes in these traits are shown, which of the tips has a tree habit and lacks true leaves? So we're looking for someone that has a tree habit and does not have leaves. So it's an herb. So if I go up this way, this one becomes a tree. So it could be this one, but it's an herb. And if I go up here, this one never becomes a tree. So getting rid of that. Let's see, let's go from herb to tree. Here's some more trees if I'm coming up this way. So it could possibly be these for the tree, and then it's an herb, da, da, da. Okay, these never become trees. So now I'm down to just 3. So it has a tree habit, and then it lacks true leaves. Well, it starts with no leaves, so looks like this one does not develop any kind of leaves. So that could be it. And then if you go up this way, it starts with no leaves. Um, tree habit. Oh, and then they get true leaves right here and they never lose them. So that makes me cross out that one and that one. So we're left with this first one. And I think that's it.